Hi everyone. So here we have an MIT question. I'm not sure whether it's an MIT question. I just searched it up to the internet and I just found a picture. So I just thought of solving this question. So let's do it. It's not that hard. It might look hard, but it's not that hard. So what we gotta use first is we have to use this formula called integration by parts. So this is the formula for integration by parts. Okay. So we're going to take one term as u and the other term as dv over dx. Okay, it's always like that. So we're going to take the term u. So the term we take for u should be the term that's easily differentiated. It shouldn't be the term that no, how should I explain this? So it's like this. So we can't take dv over dx as sine inverse x, because we don't know what's the integration of sine inverse x, right? We can find it, but it's going to be a long process, right? So it's easier differentiating sine inverse x, right? We can straight away get the answer. So that's why we take sine inverse x as u and dv over dx as 1 over x to the power 3. Because that's easier to integrate, right? So what's the differentiation of sine inverse x? That is 1 over 1 minus x squared. I've shown this in one of my previous shorts. So it's a detailed explanation of how you. So I'll prove this, okay? So I'll be dropping the link for that. So to find v, we have to integrate this, right? So that's x to the power minus 3 plus 1 minus 3 plus 1. So v equals minus 1 over 2 x to the power minus 2, right? So now you got to use the formula. So u into v, right? So that's going to be minus half x to the power minus 2 into sine inverse x minus the integration of minus half x to the power minus 2 into 1 over root 1 minus x squared dot dx, right? Right, dot dx here, dot dx. Okay, so now we'll write again minus half x to the power minus 2 sine inverse x plus, we'll take the half outside. We can just take that outside. And now we have the integration of 1 over x squared root 1 minus x squared dot dx, right? So now what you do is, so we'll leave this one aside. Now we have to focus on this, right? So I'll write that with a different color. Please tell me if you guys have any doubts. I can explain these again. So now we have to integrate 1 over x squared over into 1 minus x squared dot dx, right? So let's take a substitution this time. So we can take a substitution of u equals root 1 minus x squared, right? So du over dx equals, so I'll just rewrite this like this, 1 minus x squared to the power half. You got to understand better. So now when you differentiate, this is du over dx equals. So when you differentiate these type of formulas, equations, so half comes down, and then you differentiate of what you have inside. That's minus 2x into 1 minus x squared, and this becomes half minus 1, right? So that's basically minus x into 1 minus x squared into minus half. So you can rewrite this as minus x over root 1 minus x squared, right? Du over dx. It's subject du. So, no, sorry, dx. So we have root 1 minus x squared over minus x dot du equals dx, right? We're subject dx because we need to get the formula for the integration in terms of u, right? So now you can write 1 into x squared to root 1 minus x squared into, so dx. Now you put in, I don't have enough space. Okay, I'll just write it again. 1, so root 1 minus x squared over minus x, right? Dot du. So now you can see, I can cancel these off. And now I end up with the integration of minus half. Sorry, not half, I'm sorry. It's 1 over x cubed, right? It's 1 over x cubed. So now we need to find x cubed in terms of u. Because if this is du, this has to be in terms of u, right? So we have u equals root 1 minus x squared. So what you do is, let's square both sides. So now we have u squared equals 1 minus x squared, right? Now we subject x squared. So you take x squared onto the left side, it becomes 1 minus u squared. Now, to make this x to the power 3, what do we do? So we have to do this to both sides. So to the power 3 over 2. Because you can see x to the power 2 into 3 over 2. When it's in brackets, you multiply the powers, right? So you can see the 2's cancel off. So we have 1 minus u squared to the power 3 over 2, right? So now you have to integrate 1 over 1 minus u squared over 3 over 2 dot du. Now it's easier. So here comes another substitution. Now we have to take another substitution. Alright, they get another. Okay, so this is what we end up with. So when integrating this, let's say, we can take a trigonometric function, right? I'll show you. So we can take u equals sine w. So du over dw equals cos w, right? Differentiation of sine w is cos w. So now, when you put it in your equation, so it's going to be 1 minus u squared. So u squared is sine squared w, right? 3 over 2. And let's subject du over here. So du equals cos w dot dw. So we can write cos w above dot dw, right? So now, can you see 1 minus sine squared w is cos squared w, right? So it's cos w over cos squared w to the power 3 over 2 dot dw. So what do you do with cos squared w to the power 3 over 2? So can you see these powers? So we can rewrite this as cos w to the power 2, right? To the power 3 over 2. Can you see these powers cancel off? So you end up with cos to the power 3, right? This is about 3 w. So now you can write cos w over cos to the power 3w dot dw. So you can see these cancel off. So you end up with the integration of 1 over cos squared w, which is the integration of sec squared w, right? And now it's very easy. So what's the integration of sec squared w? Easy. Tan x. So it's minus tan x plus, sorry, not tan x, I'm sorry, tan w. Minus tan w plus c. So now let's put in our substitutions. So we had a half in front too, right? Yeah, we had half in front. So it's going to be, so your final answer would be, alright, that with black. So we had minus half x squared into sine inverse x Yeah, because it's x to the power minus 2, so you can take it down, all right. Just took it down, sine inverse minus half tan w plus c. So w, we took the substitution. Okay, so we have u equals sine w, right? So w equals sine inverse u, right? So minus half 1 over 2x squared into sine inverse x minus half tan sine inverse u plus c. Now we had a substitution for u previously, right? So what was u? U equals, okay, u equals root 1 minus x squared. So your final answer would be this, minus half tan sine inverse root 1 minus x squared plus c. Big answer. Long question. But this is not your final answer, because that's not what they're asking, right? So if they ask you to interpret, this is the correct answer. But they've given us two intervals, right? They've given us the intervals of half tan sine inverse root 1 minus x squared 1 root 2 over 2. Okay, now you put in the intervals, so you got to use your calculator for that. So when you substitute 1, we get minus pi over 4, because this is the only part we have to deal with. This is 0 anyways, we don't have to worry about that. So minus pi over 4 minus, now we substitute root 2 over 2, and that's minus pi over 4 again, minus, so let's substitute root 2 over 2 into tan, that giving you minus half. So it's going to be minus pi over 4 plus pi over 4 plus half, right? So your final answer, you cancel off pi over 4 and your answer is half. To get this value, we had to do so much calculations. Yeah. So I hope you all understood. If you guys have any doubts with any section, please drop them in the comment section. Any doubts, it doesn't matter, I can explain this again. So if you guys have any doubts, I'm repeating again, please drop them in the comment section. And if you like my teaching, leave a like and subscribe, and have a great day. Thank you so much.